Hi, I'm going to try to help you a bit with converting between metric units and then using proportions to convert between metric and English/American units. First, I thought since we're doing math, I'd show off my geeky math shirt that says the square root of -1, 2 cubed, the summation symbol, and the pi symbol. And then underneath it says, and it was delicious. Well, the square root of -1 is equal to the imaginary letter I, and 2 cubed is the same as 2 times 2 times 2, which is 4 times 2, or 8. The weird looking E is a summation symbol that means to add stuff up. And then, of course, the famous pi symbol. And so we're left with, I ate some pie and it was delicious. So that's my geek shirt for our math material. And here we go. I have a little mnemonic device. Mnemonic means memory trick. And it is that King Henry died upstairs drinking chocolate milk. Poor King Henry. Well, what we can do with these letters is to think that the letter K goes with kilo. The letter H goes with hecta or hector. And I think that one's usually a capital H. The die is a deca, which there's different ways of spelling it. Sometimes I see a DKA, and it can be abbreviated with DA. I'll make this a lowercase h. Upstairs, this is going to be our base unit. And the three that we'll mention the most are the gram, the liter, and the meter. Then getting smaller than those, we have our deci, which is just the letter D. Chocolate goes with centi, which is the letter C. And milk goes with milli, the letter M. And what I'm able to do then is to use this order of letters to help me convert between things like saying we have maybe 55 grams, and we want to know how many milligrams that is. The trick is that we can first see how many places to move the decimal. And then second, move the decimal in the number. Lastly, if there's any empty spaces, they get filled with zeros. So you ready to give it a shot? Say we want to do 55 grams equals a certain number of milligrams. What I do is I first write down the letters. King Henry died upstairs drinking chocolate milk. And yes, I put the D, that this is our deca versus deci, because I'm just looking for an easy way of recopying the numbers. And I really almost never use deca or deci, really. The main guys are going to be our kilo, our base units, centi, and milli. Those will be the ones that we'll use the most. Okay, so what happens? Well, I start with the decimal, place the decimal directly under the original unit, the undesired original unit. Okay, well, we're starting out with grams. That is one of the base units. Okay, so I'm going to put it right here. This is where our gram will be, directly underneath. Now I'm going to move it over to the desired unit. Under the desired unit. All right, well, let's see. Milli is over here. So I'm going to go swoop under the D, swoop under the C, and swoop under the M for milli. I've moved the decimal 1, 2, 3 places to the right. I'm going to now do that with my 55. There's no decimal drawn, but there's an invisible decimal there at the end of the number. So I'm going to start there. And I'm also going to move it 1, 2, 3 places to the right. I'm going to fill in all those extra places with zeros. That tells me that 55 grams is the same as 55 with 3 zeros milligrams. And do it again. Okay. What if I have maybe, I know, let's say we have 55 grams and we want to know how many kilograms that is. Same thing. King Henry died upstairs drinking chocolate milk. I'll start under the base unit again because I'm still with grams, but this time I'm going to go swoop, swoop, swoop 3 places to the left. Let's do the same thing with our number. The invisible decimal goes 1, 2, 3 places to the left. That tells me that 55 grams is the same as point. We had one empty spot. I can put the 0 there. 0, 5, 5. My unit is kilograms. And I can put a 0 in front just to make sure I know that there's a decimal coming up. That's especially important if maybe the decimal was directly in front of the first 5. It helps out with that. They both have 2 significant figures. The 2 5s are both significant figures. These 2 5s are both significant figures. The zeros in front are just placeholders. Okay, I'm going to give you a couple more and then you can pause the recording and give those a shot. And I'll post an additional list of practice problems and an answer key for you to go with it. So here's our examples. I want you to try going, we're going to go between 0.85 meters, and we want to know how many millimeters that is. Remember, 1 m means meter, 2 m's means millimeter. Then I want you to also do, that'll be example number 1. And example number 2, how about we do something with liters? Maybe, what if we did 5,230 milliliters, and I want to know how many liters that is. Okay, go ahead and pause the recording. I recommend that each time you go through and you write down the letters, the K, H, D, U, D, C, M. The more times you write down that pattern, and don't feel like you have to do King Henry died upstairs drinking chocolate milk. What the neat thing about these mnemonic tricks, it's spelled M-N-E-M-O-N-I-C, related to memory. And what about it? It helps if you come up with things that are silly or maybe a little scandalous, and that way it'll stick in your memory better. But you don't have to use the ones that are given to you because those may not click as well for you. Go ahead and have some fun coming up with words to represent KHD or DA, U, or whatever you want the base unit. It could be a B. I've seen people, I used to say Monday instead of upstairs to stand for main unit, but then people got confused because there were so many M's. But also you could think of it as, as a B as well for base unit. Then the D, C, and M. And if you want, you could always keep going because after milli, there's also micro, which looks kind of like a U, and nano. So you could always add on some extra words to it if you wanted to remember those are the next two in line after milli. All right, I'm gonna assume you're pausing the recording and come back. Okay, welcome back. So here we go. We've got to convert between metric units. I know it's metric units and not English or American units because it has the term meter, liter, or gram. The goal then will be to do King Henry died upstairs drinking chocolate milk. My decimal is starting directly under the U for the base unit. And then it's going over to the little m for milli. So one under the D, one under the C, and ending up underneath the little m for millimeter. My number 0.85 needs to also then go 1, 2, 3 places to the right. 0.85 meters is the same as, go ahead and put a 0 up there, 850 millimeters. If you've watched the information about the significant figures, then you might notice that this number here has only 2 significant figures, which means I can only have 2 significant figures over here. I will not draw a decimal point because I don't want the 0 to be significant. Just leaving it as 850 with no decimal point is the way to get 2 significant figures, just like in 0.85. Example number 2, again, I'm talking about liters. So I know I can use King Henry died upstairs drinking chocolate milk. This time, we're going to start under the M for milli. And we'll move it 1, 2, 3 places to the left to get under the base unit for liter. 5, 2, 3, 0. There's an invisible decimal at the end of it. 1, 2, 3 places to the left means that I now have 5.23 liters. What do we do with the 0? Well, up here, the 0 was not significant because there was no decimal in the number. Zeros at the end of numbers with no decimals are not significant. That means I don't want to recopy them down here. Now I have a decimal point. If I put a 0 at the end, it would be significant, and we're not allowed to do that. 3 here, 3 significant figures here as well. I hope this has been helpful for you. What I'm going to do next is show you how to do unit conversions using proportions. All right, so what shall we do? How about one that can help my nursing students? We could do 1.5 oh no, how about 16 ounces equals 1 pound LB. And this, if you're trying to get into nursing school, you're going to want to have that memorized. And then let's say I'm asked for, I don't know, if we had 28 ounces, and I want to know how many pounds that is. This is about doubled, so this will be close to 2, but if I want an exact number, I'm going to need to set up a proportion if you didn't like the method that I showed in the other video. We have 2 units and 3 numbers. We're going to solve for 1 missing number. And we're going to call that guy X. You can call it whatever letter you want. Use the first letter in your name, I don't care. But X is pretty traditional. Then we can set up the proportions. There are multiple ways of setting up the proportions. You can pick one way of doing them. One way, the way I typically choose to do it, I pick one of the units, because remember, there's 2 of them, and I put him on top on both sides. Then whatever the other unit is, I put him on the bottom on both sides. The rule is that these units here, the numbers that go in with them, must make these 2 equal to each other. So these must be equal or related to each other, maybe equivalent could be a word. For example, the 16 ounces and 1 pound, not 28 ounces and 1 pound. These guys were equal to each other. The 28 ounces has nothing to do with 1 pound. Same for over here. These 2 guys have to go together. The other way you could do it, you could have unit 1 over unit 1 is equal to unit 2 over unit 2. In this case, these guys on top must be equal or related to each other. You can pick whichever method you prefer. Sometimes I do it differently depending on my mood, but I do make sure if I'm going to keep the same unit on both sides on top, then I make sure the guys that go in the fraction on the left are equivalent and the ones on the right are equivalent to each other. If I decide to do it in this format, then I make sure that the 2 guys on top are related to each other and the 2 guys on bottom are related to each other. Let's try a practice problem. We have the 16 ounces is equal to 1 pound. That's just a known definition. And we want to know 28 ounces is equal to how many pounds? Well, if I do it the first way, again, I could pick whichever one I want on top. It really doesn't matter. And I could decide who goes on the left and who goes on the right. The neat thing about this particular style is it doesn't matter which unit's on top and which one's on bottom, as long as you're consistent with the other rules. Let's do, I really don't care. How about ounces on top, just because I wrote that down first. So 16 ounces will be equal to 28 ounces. The 1 pound needs to stay with the 16 ounces. These guys equal each other. Over here, well, I don't know what is related to 28 ounces. That's what I'm trying to find out. So this is where I would put the X pounds. to solve for x, you need to cross multiply. Where should I write that? Cross multiply. This is why it's so important that you choose one method. Because of the equal sign, we cross multiply. With the factor label method that I taught in the other video, that one's different. That one has a times symbol between them. Then we multiply across the top and divide, divide, divide by everybody on the bottom. If there's an equal sign between them, if I'm using proportions, then I cross multiply to solve. I usually pick the guy that's across from the x. So I would say 16 times x is equal to 1 times 28. Right? 16x, therefore, is equal to 28. This won't always be a 1. I realize you may have been able to solve this without needing to do anything special, but this will not always be a 1. 16x equals 28. Right now, we have x on one side and a number on the other. I need to get all my numbers over to the right-hand side, away from the x. All right, well, for 16 to run away from the x and go to the other side, we have to do the opposite of what is happening to him now. Right now, it's 16 times x. The opposite of times or multiplication is division. I'm going to divide by 16. If I do it to one side, I have to do it to the other side of the equal sign, just to keep it equal. 16 divided by 16 is equal to 1. Any number divided by itself is equal to 1. And that becomes invisible, just like it did up here. 28 divided by 16, got my handy dandy calculator, and 28 divided by 16 is equal to 1.75. You don't have to worry about using fractions for me. If you're going to be taking the TEAS test to get into nursing school, then let me know. I can teach you some tricks for how to solve the problems that have fractions in them. But this will be what we have right now. X equals 1.75. And if you want, without getting overwhelmed, you now have been shown how to find the value for X when you're given 3 numbers and 2 units, and you need to solve for a missing value. Remember when I said that 16 times 2, we're getting close to 28? And so here we are with 1.75, not quite 2 as well. So this number makes sense. If you're ready now, we need to do one more step. 28 ounces, 28 has 2 significant figures. We did multiplication and division, so our final answer also must have only 2 significant figures. 1.75 has 3 significant figures. I'm going to have to drop one of those. So I start with the 1, keep the guy to the farthest to the left. Now the second guy, is he going to stay a 7 or round up to an 8? I look next door. He's 5 or more. So when it's 5 or more, we add 1 to the number that we want to keep. So this will become 1.8. I'm going to remember my unit. Even though Connect homework assignments typically give you the unit, you're going to remember to put your unit so you don't lose extra points. You're going to get points for the right number of significant figures and for including your unit. So please don't forget either one of those things. But if you need to, for now, just make sure that you're comfortable with what we just did. You may not have wanted to solve it this way. Perhaps you decided you wanted to solve it the other way. I'm going to show you how it would have still worked out if we'd done the other approach. If we had said maybe where we do the unit 1 over unit 1 equals unit 2 over unit 2. The neat thing is that by cross multiplying to solve for x, it doesn't make a big difference. The only thing that matters is that these guys have to go together. Okay. So it doesn't matter. Shall we put ounces on the left? And whatever you want. You want to put the big guy on top this time? So we'll do 28 ounces over 16 ounces is equal to, okay, now let's be careful. The unit on this side, they're both going to be pounds, but what numbers are we going to use? 16 ounces equals 1 pound. So I need to put those guys together. On the top, 28 ounces is equal to an unknown number of pounds. So we can do it this way. I kind of like that. I usually teach it the other method, but I kind of like how it went 28 ounces equals X, 16 ounces equals 1. I think I might start teaching it this way instead. I like that. Okay, so we would cross multiply to solve again. 16x is equal to 28 times 1. And then x is equal to 16x is equal to 28. The 16 needs to run away again. So I divide both sides by the 16. These guys cancel out, and I'm left with an invisible 1x. And again, this will be 1.75. Our answer then is 1.8 pounds. Put it in a box to make it easier for me. I'm going to give you a practice problem to try, and you can pause your recording and then come back when you're ready. My question now is, I don't have a lot of stuff memorized, but I think we did one where I said for fun, we would say that a 5.0 kilometer race is equal to 3.1 miles. And I want to know then if I do, I don't know, I'm debating whether or not to do, let's say, a, I don't know, 14 kilometer trip, and I want to know how many miles that is. 2 units, 3 numbers, 1 missing. You can solve this using a proportion. I'm going to let you pause and set up your proportion. Again, there's a couple ways to set it up, but in the long run, we should have the same answer. All right, go ahead and pause. Hi, welcome back. Hopefully you paused and you're ready to continue now. I'm not sure which way you liked it, but seeing how I just said I really enjoyed doing the equals thing, I'm going to go ahead and do 5.0 kilometers is equal to 3.1 miles. And on the bottom, I'm going to have the other kilometer, 14 kilometers, will be equal to question mark miles, so X miles. Cross multiply to solve. 5.0x is equal to 14 times 3.1. And let's see what that comes out. Oh, well, yeah, we'll do it the slow way. 14 times 3.1. Oh, 14 times 3.1. 43.4. And you may be wondering why I'm bothering to put the 5.0 here. what I found interesting when I was grading tests last semester, I found that people who dropped the point zeros and continue with the problem, they forgot to go back to the original numbers and make sure how many significant figures they had. So if you think you can be really good about going back to the original part of the problem and checking your significant figures from there, then it's fine to just keep writing 5x, 5x. But if you think you might forget, and so you need to include all significant figures, even the zeros, as you go through, then this might be the better way to write everything out. Okay, my goal is to have x by himself. Right now, he's being multiplied by 5.0. So I'm going to do the opposite. I'm going to divide both sides by 5.0. Be left with x equals, I'm just going to hit divided by 5 in my calculator, 8.68. Two significant figures, two significant figures, two significant figures, three significant figures. So the final answer, 14 kilometers, is the same as 8 point, I only get one more, so 8.7 miles. Does that make sense? Well, when we go from 3 to 5, it's not quite twice as much. 8 to 14, it's not quite twice as much. So yeah, this worked out pretty well. If you set it up instead as something like 5.0 kilometers over 3.1 miles is equal to 14 kilometers over x, you still would have had 5x equal to 14 times 3.1. Everything's still the same if you've done it correctly, if you've made sure that these guys here are equal and these guys here are equal. And if the guys on top are equal and the guys on the bottom are equal, then you're going to be okay. All right. So keep going through the problems. There's tons of problems plus on Connect. And the difference is that if you really feel strongly against using the factor label method, then you're going to need to use this method. What I didn't do was show you if we have two sets of units that we have to go through. And I guess I better do that. Okay, so let's say, what was the one we did in class? Can't quite recall. I know what it was. It was the yards to centimeters. Okay, and which way is the harder one when you put centimeters first? So let's say we have, I don't know, 4,200 centimeters, and you want to know how many yards that is. Oops, bring it on down. Okay. Oops. And then we know we're given that 1 inch is equal to 2.54 centimeters, and 36 inches is equal to 1 yard. This time, we have 3 units, 5 numbers, 1 unknown. This is going to be solved with 2 proportions. Okay, well, 4,200 centimeters. I'm going to start there. That's the number with 1 unit. Can I go directly to yards? I don't have any information here. I can't say this is related because 2.54 centimeters definitely does not equal 1 yard. What the centimeters does equal is 1 inch. So I can do my first proportion by saying that it's equal to an unknown number of inches. On the bottom, I can put the information that 2.54 centimeters is equal to 1 inch. Or I can say 4,200 centimeters. Put centimeters on top on the left and the right, and then put X inches on the bottom and inches over here. This time, the 1 inch is equal to 2.54 centimeters. This is really important that you keep your guys together, whether they're both on the bottom, or both on top, both on the left, or both on the right. Pick a pattern and work with it. I'm going to stick with this one because I really am getting a kick out of this equals that. I like that a lot. So what are we left with? Cross multiply. 2.54 x is equal to 4,200 times 1. I'm just going to go ahead because I don't feel like rewriting it another time. Divide both sides by the number that's next to x. It's known as a coefficient. All right. And what happens next? Those guys disappear. I'm left with 4,200 divided by 2.54. All right, and it's a big number. I'm going to write down just a few of the numbers. In the long run, it's really not going to matter. X equals 165, it says 53.5, so I'll say 54. Okay. And what's the unit for that? Come back up here, I see the X was inches. This makes sense. If it takes 2.5 centimeters to be 1 inch, half of 4,200 would be 2,100. And this is another proportion less than that. So it makes sense that I'd have to multiply by 2.5 to get from here to there. All right. Now, we're not done because we're trying to find out the number of yards. We have information about yards in inches, so that's what we'll do in our second proportion. The 1,654 inches, we don't know how many yards that is. Inches on top, inches on the bottom. So we'll work with the 36 inches and have that equal 1 yard. Make sure that you're not going with 1 inch again. That was back when we worked with centimeters. Now we want to work with the 36 inches because we're thinking about the unit yard. Go ahead and cross multiply to solve. 36x is equal to 1,654 times 1. Divide both sides, get that 36 to run away over to the other side by doing the opposite of what he's already doing. I still have my last number in my calculator, so I'm just going to hit divide and then 36. That way I'm keeping all of my significant values and digits in my calculator until the very last step. As much as possible, I try to don't hit clear until I get to the end of the problem because I want to try to keep as many numbers still in my calculator to have the most accurate answer. And if your calculator isn't able to work with you that way, it's okay. It won't make a big difference. Because I even set up Connect that it has a little bit of tolerance. So if you put 45.1 instead of 45.3, it'll still let you have it correct. But now if you put 46 or something, it won't be correct. All right, and here's what we have. We have x is equal to 45.93. It keeps going, but that's an easy place to stop. Okay, our unit is yards. We have a much smaller number than what we started with originally. with 4,200 centimeters now just being 45, 46-ish yards. I have my unit, but I may not have the right number of significant figures. The 2.54 and inches, 1 inch, those are definitions, so we're good on that. 36 inches equaling 1 yard, that's another definition, so I'm not going to worry about those for significant figures. Instead, I'm just going to go back to the original value, 4,200 centimeters. There's no decimal, so the zeros are not significant. This is only 2 significant figures. Therefore, 4,200 centimeters is equal to 4, and instead of a 5, his neighbor next door is 5 or more, so I'm going to round this guy up to a 6. 46, I don't need a decimal because, it's not trying to say whether the 0 at the end is significant. And I put the unit and I put it in a box, and then I'm done. So this definitely takes longer when you compare it. If you go back now and watch, or you will see me during sessions helping solve problems using the factor label method, that's still going to be my primary method because it's so much faster. Just setting the guys up and times across the top and divide, divide, divide on the bottom. I don't have to keep setting up these things. And granted, some of you are going to be like, well, all I had to do was multiply by a number or divide by a number. And, that's great. I have found that people tend to make errors in terms of whether they're supposed to multiply or divide, but not always. Not always. If you're good with setting these up or not even needing to, if the other value is a 1 and you know immediately, oh, I'm going to a larger sized unit, so I divide, or I'm going to a smaller sized unit, so I multiply, that's great. Do it however you need to do it. I just haven't taught this way before to help students, and I wanted to make sure you had this option if you decide you want to use it. All right, well, hopefully I'll see you in some of the live sessions soon and can answer any more questions you may have. Bye. All right, and Alt.